Hi, I'm Tim Shu from San Jose State University. I'm here to talk about 4 ways to describe a function. So after a brief introduction, I'll get to the 4 ways listed here. So without further ado, the goal of this video, the point of this video, is to discuss 4 different ways to describe a function, either by formula, by its graph, by a table of data, and by its verbal description. And the point of all this is that while you may be used to thinking about functions in terms of formulas, that may be the way you've sort of done math all your life. When you actually use calculus in practice, if you actually were to use calculus in a way that someone would pay you money for, God forbid, you were actually more likely to encounter functions described in one of the other ways, not as a formula, but in terms of a graph or a table of data or a verbal description. So throughout this course, you'll see problems that use all of those methods. The one you're most familiar with is probably describing a function by its formula. So recall that a function f of x, what do you need to have a function f of x? You need a domain, which is the set of all its possible inputs. You need a range, which is the set of all its possible outputs. And you need a way to describe what the output f of x is that corresponds to a given input x. So this last part of the description of f of x, which is sort of comes with these 4 different methods, can be given by a formula. And one of the most famous ones is probably f of x equals x squared. So here that means if I'm the function f, hi, I'm f. If you give me x, I'm going to return x squared. All right, another way to describe the output f of x corresponding to a given input x is by its graph. And one of the oddest things about calculus is that one of the most important things about the graph of function is actually knowing its definition. So here, I'm sure haven't thought about this for 10 million years. Here's the definition of the graph of a function. So the graph of a function f of x is a set of all points x, f of x in the plane where x is in the domain of f. In other words, for every x that's in the domain of f, we color in the corresponding point x, f of x. So here's an example, the graph of f of x equals x squared. So consider the graph of f of x equals x squared, and there it is. So pop quiz, what are the coordinates of the blue point? So let me give you a few seconds to think about it. Tick, tick, tick. Okay. So hopefully what you realize is that because the x coordinate of that blue point is 5, the y coordinate of that blue point must be f of 5, which is 5 squared, which is 25. So this here is really 5, 25. But in general, if this were any graph, as long as 5 is in the domain of f, then the corresponding point in the graph will be 5, f of 5. Now, you would not believe how often you use that in calculus. It's really very frequent, and so it's very important that you have that idea solid. Okay, here's another way to describe a function. So you can describe it by a table of data. So instead of saying what the output is f of x is for any random x, you could just give f of x, say what f of x is for some sample values of x, just some of them, not all of them. In other words, we can describe f of x by a table of data. If you think about it, that's what a table of data is. Often, if it's a table of data describing a function, you have one column describing the inputs, and you have another column describing the corresponding outputs. And with the idea that there are probably other values of x for which you could get f of x, but you just don't know what the values are. Right, so for example, what this table says is that if you put in the input minus 0.47, then the output is 0.2209. So f of negative 0.47 is 0.2209. So note that while a table gives only limited information, it's probably the form of function that you're most likely to encounter in nature. And by limited information, let me point out that I actually made this table by using the formula f of x equals x squared. So if you look at this table, it's not so easy to tell that maybe this actually does come from some sort of function modeled by x squared. Anyway, but this is what the form in which you're most likely to encounter a function and get paid money for it. If you do this for a big enough table, they call this big data, and we call that cha-ching, money, baby. All right, and so finally, sometimes functions are given by verbal descriptions, and here's a famous example. The kinetic energy of an object as a function of its velocity is proportional to the square of its velocity. So translating from the physics, if f of v is the kinetic energy of some object as a function of velocity v, then f of v equals kv squared. So that is proportional to means is equal to a constant times. And so this is actually yet one more way of describing, roughly speaking, except for that constant, the function x squared for some unspecified constant k. All right, anyway, that's enough for now. So go do something useful. Thanks, bye.